Hello everyone, and welcome to your video on log bases. So let's say that I told you that the log of 16 you needed to calculate. And so you would pull out your handy dandy calculator and you would punch in the numbers and you would get that the log of 16 is about 1.204. But the question that is probably burning inside of you is, what does that really mean? Well, I'll tell you what it means. It means that the number 10 raised to 1.204 equals 16. You take a base of 10, because 10 is the base of our math, right? So you have numbers 1 through 9, and then you hit the tens place, and then you get 10 tens, and then you get the hundreds place. Everything is kind of divisible by 10. So you take the base 10, you raise it to 1.204, and you get 16. So this information right here says that the log of 16 is 1.204, which means that 10 has to be raised to 1.204 in order to reach 16. If you wanted to, when you're asking what is log 10, you're really asking what number, what is log 16? That is, what number do I have to raise 10 to equal 16? Okay? What number do I have to put here in my exponent in order to get 16? Let's look at another one. What if I said log 3? What does that mean? Well, it means 10 raised to what number equals 3? 10 raised to what number equals 3? So you pull out your handy dandy calculator and you figure it out. And you get log 3 of about 0.4771. So that means that 10 raised to 0.4771 is about equal to 3. Go ahead, test it if you don't believe me. It works. Okay. What about log of 2,000? What are we really asking here when we ask what is the log of 2,000? Well, we're saying that if you have 10, what number do you have to raise it to in order to get the number 2,000? And when you put that in your handy dandy calculator, you get that it is 3.301 about, which means that if you take 10 and you raise it to 3.301, you will get 2,000. So that is what a log is. It is, what exponent do I have to raise 10 to in order to get the number that I'm after? Okay, so far so good, right? Cool. All right. However, logs do not always have to be written like this. Like, you'll notice that this is log and there's no little subscript down here. It's just log and then a space and then the digits 1 and 6. Not all logs are written like this. For instance, I can write this. I could write the log of base 3 81. What does that mean? Well, that means that I want to take 3, I should put this over here, 3 raised to the x to equal 81. So instead of having a base 10, now I have a base 3. Base 3 raised to the what equals 81. And, right, that's it. Nothing here in this intersection. Okay. So if I did log base 5 20, what would I be saying? I would be saying, well, if I have a base of 5, what do I have to raise it to in order to get to 20? And you know how to solve these problems, right? You would take the log of both sides, you would use the birdie rule, you would divide, and you could get an answer for that right there. Okay? And the numbers can even be more complicated. For instance, I could have a log of a base 1.25, 93. What does that mean? Well, that means I have a base of 1.25. What do I have to raise it to in order to get 93? Now, these numbers, these logarithms here, they have these base numbers, and up here there are no base numbers. And the rule is that if you don't see a base number, you just assume that it is a 10, because we live in a base 10 world. So most of the logs that you see are base 10 logs, and so they don't even bother showing what that base number is. These, they do show because they're something different than base 10. Okay, so this helps us understand what is a logarithm. A logarithm is the number that we have to raise 10 to in order to get the desired result. The number that we have to raise 10 to in order to get the desired result. That's the end of bases.